Hello all, my name is Rahman and welcome back to my YouTube channel. So guys, in this video we are going to apply the k nearest neighbors algorithm to a data set. So guys, if you remember in the last video, we have talked about the k nearest neighbors algorithm and support vector machine algorithm with the classification. But guys, we are going to use the k nearest neighbors algorithm in a data set. In that video, we have talked about a data set where you are having two groups where in each group we were having three dots. So guys, what if we get a extra data point? So in which way do we want to assign that that data point? Okay. So guys, for assigning the data point, you have to use the k nearest neighbors algorithm for them. So guys, we have talked about that in the last video, but guys, in this video we are going to apply the k nearest neighbors algorithm to a data set. So guys, let's go ahead and get started. So I have already kept the notebook open. Now, so guys, we don't have any data sets right now. So guys, I'm going to choose a data set from the archive UCI. So so guys, from this website we are going to get a lot of machine learning data sets. So guys, this is UCI machine learning repository. So this UCI machine learning repository is a collection of databases, domain theories, and data generators that are used by the machine learning for the learning community for the empirical analysis of machine learning algorithms. So guys, as you can see here, we can find lot of machine learning datasets from here. So this is an American website, University of California. Okay, so guys, as you can see here, we have the new datasets, we have the latest datasets, and here we have the most popular datasets since from the 2007. Now, so guys, from these datasets, here we have to choose a dataset. So guys, let's see that which dataset to use. So I have already choose the dataset. So guys, from these most popular datasets since 2007. So from here I am going to choose this one, best answer dataset. Let's click on this one and it's going to open. As you can see here guys, we got this dataset. Now guys, what we have to do is we have to download its description or we can download the dataset with the folder. Now let's download with the folder only. So I have opened that in the new tab and you can see here guys, we have this cancel constant data and we have the names. Now if I click on this data, I have to download this one. So let's do that in the downloads, and here I have to download the names also. Let's download for the same thing as in the names only. Now, so guys, let's check whether the data sets downloads. No. So let's move it to the brave itself. So guys, in this case, as you can see here, we have the data sets that are written here. So you can see these breast cancer databases were obtained from the University of Wisconsin hospitals. So anyway guys, we are getting all the information here. Now let's take this one data file. So guys, as you can see here, we have a lot of numbers. If I scroll down and you can see all we have is all of these numbers. Now, so guys, let's recheck the another file we have, that is I will show you in my file folder. So if I go to the downloads, we have this is the data file and this is the names file. So I forgot to show you this one. So guys, as you can see here, we have the sample code number. So guys, we have the clump thickness, we have the uniformity, view of cell size, we have all of these things, right? Now guys, what I'm going to do is make some changes. So let's open the another data file, which is this one. Right, click this one and I'm going to open this with the notepad. Okay, now so guys, here I am going to add here these columns like ID or array. So here I am going to add here the ID number, the domain, the sample code number, etc. So let's add that one. First of all, where is this one? Above this one I am going to add here the ID. Then beside this one I am going to add the clump. So I'm going to open this one again. So I've opened this one again. Now let's start in this way. Now, thickness, okay, clump thickness we have, and we have the unif cell, unif cell size. Okay. So guys, here I have to write here the column names, all of those things, like I was having the unif cell, and I have having the unif cell shape, and I have the simple, etc. So guys, I'm going to type all of those things here. So guys, as you can see here on the screen, I have entered all of these things, like you're having the sample code number. So for that one, I have given the thickness, uniform cell size, etc. Okay. Now, so guys, what we have to do is we have to open the Jupyter notebook, and then we have to make here the so here we have to make here some import, like we have to import the numpy as np, and below this one I'm going to import the from sklearn learn import the processing. We have to import the cross validation. But guys, if you remember some videos before, we got error while importing the cross validation, because in latest version we don't have the cross validation. We have something like, if I show you, from SQL model, select model selection, import train test split, we have this one. So guys, I'm going to paste this at the bottom of this one. So let's paste it, and here pre-processing, I'm going to import here the neighbors. Now guys, let's run it and check whether it's going to work here or not. So guys, as you can see here, we didn't got any errors, which means that these are installed on our computer. So guys, we have forgot the pandas library for importing. So now let's import this one. So below the numpy, import pandas and pd. Okay, now we have imported. Let's run it. Now, so guys, here I am going to use here create a variable known as data frame df, which will be reading the CSV file. But guys, if you see in the downloads, we have these two files. So I'm going to cut this one. I'm going to change its properties for okay. So anyway, guys, let's Control X, and I'm going to paste it in the code. Now, so guys, I'm going to change the properties for this one. Properties. The properties for this one. Now I'm going to change it to the browser. Okay. Apply this one. Okay. Now we have all of these things right now. So guys, let's create the data frame. Data frame equals to pd dot read CSV file. Right. So guys, for doing this one, I'm going to use this and copy the file name. Let's close this one. No. Okay. Now from here, where I am the machine learning in Python, here I am going to copy the list cancel these two things. Data file we have. So I am going to copy this name. Copy, and let's take where is the okay. Now let's paste it here. We have the breast cancer, this console. Okay. Dot data we have to do, right? So we have two files of the same name data, and we have the names. So let's use here the data and let's run it. So guys, but guys, before running this one, we have to replace the data frame. So guys, if you have seen there in the, if I show you those files, I'm going to show you those files in the data and in the names. Right click, and I'm going to open this view of that. So if I scroll this down, and with this guys here, if you are seeing here, we have the class distribution, and we are missing attributes, we have values, and there are 16 instances in the groups 1 to 6 that contain a single missing, that is unavailable attribute value. Now it's denoted by the question mark here, right? So the things that are denoted by the question mark means they are missing. So guys, what I'm going to do is I'm going to replace those things. Replace the question mark with the minus negative 9,999. Now 9,999, and beside this one, we have to import in place equals to 2. So guys, let's open the breast cancer Wisconsin file, data file, and then let's check whether are there any unnecessary columns are available or not. So guys, if I open this one, as you can see here, in this one we have the ID, clump thickness, unit cell size, etc. Now here we have to, we don't want the ID here because we have all of these things like clump thickness, etc. Now, so guys, I am going to drop the ID column. So I have just written for the references. So we don't have to remove from here. We don't have to remove from here. We have to remove from the comments. Okay. Now let's enter here the df dot drop. Okay, drop. Okay. So from the df dot drop, I am going to use here the ID. Okay. So I don't want the ID column here, and beside this one, 1 comma in place equals to true. Okay. Now guys, now what we have to do is we are going to drop the ID column here. But guys, what we are doing here is we are doing the forecasting and predicting. So guys, if you remember in the video of the forecasting and predicting, where we have done a lot of things similar to this. So I'm going to show you my GitHub slash. Let's open this one, and if I show you learning with Python. Okay, so guys, in this one, if you see regression forecasting and predicting, so I have done a lot of things similar to this one. So where I have here. So where I have used this x train, x test, x y train, y test, and we have done the linear regression there. But right now we are doing the neighbors, nearest neighbors, right? So here we are going to use the same method, but we are going to change the algorithms in this case. So we have the forecast out. So now I am not going to use these things, but I am going to use some of the things from x train, y train, etc. Okay. So guys, this. Now we have the drop ID and name. Now I am going to create a variable x should be, that is x equals to np.array, and guys, we should drop the df.drop the class. This class. Okay. Now guys, beside this one we have the np.array df.drop, and we have the class, right? Now we have the class, beside we have to add a 1. Now let's create another variable for the y, but guys, here we have not given in parentheses. Okay, y should be equals to same thing, but this time I'm going to make minor changes. Now I don't want to be here this df.drop. Okay, and this one should be also not there. Okay, now we have the y should be np.array numpy array, and should be the data frame classes. Now what you have to do is here we have to add this data frame. Now what you have to do is you have to do the same thing as we have done here, like x train, x test, we have the y train, y test. You have to do these things. Now let's copy this, and here, because I am going to paste it here, x train, y test, and we have the train test split. So guys, what we have to do is we have to use it cross validation, but guys, as I said you, cross validation is not available for the latest versions. Okay, for the new versions. Okay, now we have the train test split, and in this case we have the capital X and small y, same thing, and we have the test size should be 0.2. Now our work is not done here. We have to add here the, not this thing. If I show you, we have to create this variable CLF, and we have the linear regression. We have to do all of this stuff here. Okay, not linear regression, we have to do with the k-nearest neighbors. So let's give here the classification. Classification should be equals to neighbors, and in this case I am going to use a kn. Okay, kn neighbors should be in the brackets. Sorry, it should be in the uppercase, and here classifier. Now guys, here brackets, same thing, and here we are going to use the CLF fit. Here you can see left in this like x train, y train. Now let's paste it, but guys, I don't want this tab to be open. Okay, Let's save it. Now we have the CLF fit extreme wide range. Now guys, we have forgot one more, what we say, one more thing, one more variable, and that is accuracy. Even how much accuracy we have to get, it should be CLF dot score. What we have done last time, X test, and we have divide test, comma, Y test. Okay. Now guys, let's print the accuracy. Now, so guys, let's run this cell and let's check whether what is the output that we are getting right now. Let's run it and it's going to. So guys, as you can see here in place in PLACE. So guys, we are getting the error in the okay. Here we have okay. Here ACE. I should run this one right now. Now Y is not defined. But guys, as you can see here, we are getting this error because we have not changed the. Now let's restart the kernel and clear all of the outputs. Now let's run it from the top. This worked. Now let's run it. And guys, we have the K neighbors NEI classifier. Now let's run it. Now so guys, as you can see here, right now we are not getting any errors. Just we are getting just a warning. So let's ignore this one. So guys, as you can see here, we are getting around 95%. Here we are getting 0.9571428. And now guys, we have this is just if you calculate this one, this is 95%. Now guys, let's remove this column .x, or let's do this comment this out and rerun this column. So guys, as you can see here, we are getting the 64. So guys, there is a lot of difference. Like at the time we are getting the accuracy around the 95%. Right now we are getting around the 64%. So guys, as I said, I am saying that 95% and 64% because here we have the 64, this number. Now I am not saying, so here we are not getting any percentage symbol, but I am saying this one because if you calculate this one, we get around the 40. Okay, so anyway guys, now we have to do some more changes here right now. So this is there is a lot of difference between these two. Like we have the while commenting out after removing this line, we are getting a lot of difference from 95% to 65%. Okay, now so now let's create another column here, another variable, and that is example measure. Okay, so the example measure should be equals to some numpy array numpy dot array. Now guys, let's open this file. Like we'll have the data dot okay. So guys, let's check this out. Like how many numbers are this? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So guys, let's give a normal random number like in the brackets. Let's do something like 4, 2, 1, 1, and let's give some 2, 3, something around this one. Okay, let's make these spaces or not. Okay, now so guys, you have created this variable. Now we have to do here the predictions, right? Now let's predict okay, now I'm going to open this one. We have done the predictions accuracy. After printing out the accuracy forecast set in the video. Okay, so guys, at the time we have not done a lot of predictions at the time. Now I am going to do that prediction here. So we have the example in this prediction. It should be equals to somewhere around CLF dot product. Sorry. Okay, so it should be example measure. CLF predict example measure. Beside this one, I am going to print the prediction. Now let's run it. But guys, here we are getting key in here. Hello. Sorry. prediction. Sorry, prediction. Let's run it. Now, so guys has no idea if we are. And now guys, as you can see here, we are getting something like 65% around. But guys, still here we are getting reshape your data. So guys, from the time we were getting some error like the 1D shape or etc. But guys, this is solution for this is I have created in the column where I have given the x measure equals to example measure, and I have given something that reshape this 1 comma minus 1. And if I run it, I am getting something like 98%, 9.0, so 0.98571. Now we have these two predictions. So anyhow guys, that's all for this video. So I hope you like this video, and guys, in the description I am going to give this code, so you can go there and copy the code. And in the next video I am going to talk about Euclidean distance theory, etc. Anyhow guys, that's all for this video. I hope you enjoyed watching this video. Thanks for watching. Thank you. Bye.